Hi, today we're going to talk about problem number 2016 from AP Calculus AB exam, number 2. So it's a calculator active question. You don't really have to show your work, but you have to show setups for the problem. So what do we have here? We have a particle that's moving along the x-axis for time t is greater than or equal to 0. The velocity is given to us by this formula. And we know that the particle's position at time t equals 4 is 2. So the first question here is, well, actually, before we do anything, for these problems that are calculate active, what you always should do is you should go to y equals and plug in any functions that you have there, because it's going to be a lot easier to use it this way. Oops, that's not arcsine. We're doing sine of, and also remember, even though the variable here is t, we always use x. So that's us entering the function. When it comes to setting up the window, everything is gonna be, we start at 0, we go to time equal 4, we don't have to go above that. So I'm going to hit the window button. And for my x min, I'm probably going to choose -1. For x max, I'm going to choose, let's say, 5. For y min, I'm going to, let's try to use -3. And for y max, we'll use 3. And let's hit graph and see what we get. Okay, so here's the graph of this function. I think we picked a good window. We're able to see everything here. Alright, so the first question is, at time t equals 4, is the particle speeding up or slowing down? Speeding up or slowing down is going to require you to look at two things, the velocity and the acceleration. So this is the graph of velocity, and we can actually evaluate this if you hit the math key. Oh, I'm sorry, hold on. If you hit the second calc, we can calculate the value at x equals t equals, but x equals 4. We're going to get that value. It is not asking for a specific value. The important thing here is that it's negative. I'm sorry, positive. So we know that for part A, the velocity of 4 is greater than 0. And now we need to do the derivative at the same point to find the acceleration. The acceleration is the first derivative of velocity, so a prime of, I'm sorry, a of 4, I meant to say is going to equal to f v prime of 4. So a of 4 is going to be v prime of 4. You don't actually need to do it by hand, you can plug it in the calculator. So for that, we're going to hit second calc, and we're going to go to dy over dx, option number 6 here. And we are going to do it at point equals 4. Type it in, and it's negative. Again, it's not asking for specific values, but we just need to determine the sign. So positive velocity, negative acceleration, the particle is slowing down. Down because v of 4 is positive and a of 4 is negative. That takes care of A. B. Final times on the interval from 0 to 3 where the particle changes direction. So the particle is going to change direction when the velocity is going to change sign. So what we're going to do is we're going to take a look at the graph. So we're only interested from 0 to 3. 0 to 3 is right here. Right, let me double check my window. I'm going to 5, yeah. So that is going to be from 0 to 3. There is only one point where it happens. Right there. Because the velocity is positive up to that point and it's negative after that. This is where it stops. Okay, so all we need to do is find the X intercept here. So we're going to go to second calc, it's actually 0 that we're looking for. We need to set our left bound and right bound. So, well, we know it's between 2 and 3, so you can just manually type in 2 for the left bound and 3 for the right bound. And it's going to give you I'm sorry, I have to press. It's going to be at 2.707. I want to remind you, you must show at least 3 decimal places. So at t equals 2.707, the particle changes direction. Because, remember, it's asking you to justify the answer, because v of t changes sign at that point. Okay. Part C, we want to find the position of the particle at t equals 0. We have to show the setup here. The setup involves an integral expression. So, to find the position, we are going to have to take the initial position. Position at t equals 0. So, in this case, it's going to be the position that we know the position at 2, so it's going to be it's going to be the position at 2, so x of 4, because that's the one that we know, plus, and then you're going to have to follow it up with the integral, and the integral is going to have to go from this as your lower limit, and this is as your upper limit here. So it's from 4 to 0 of v of t dt. This is going to give you the displacement. Please be very careful, because the limits have to be in that order, unless you want to change the sign to a minus. Okay. So what we can do now is we can exit this screen. We can go to Math menu, right here. We can scroll down until we find the integral. We can use y1 of x. So for that, we are going to need our variables, y variables, y, comma, x, which is our variable, comma 4, comma 0, and also forgot to do plus 2, which was the position at 4. And this is going to be our answer, 3.815, negative 3.815. Okay. So again, the integral expression is going to give us the displacement, and then the initial position is going to be 2. So the initial position plus the displacement is going to give us the new position. Alright, so that takes care of that. And then the last question, we have to find the total distance traveled from 0 to 3. The total distance, you're going to have to use the absolute value, because the total distance traveled involves going to the left and to the right. If we look at the graph again, from 0 to that point, the particle travels to the right, and then travels to the left. Okay, so what we're going to have to do, we're going to have to go back here, and then we're going to hit the math button. We're going to go to our integral. Then we're going to go to math. No, I'm sorry, we're going to go to our menu here with the, let's see, nope. So we have to use the absolute value sign here. So the absolute value, you can, well, you can, oh, here it is, right here, the second tab on the top has absolute value of, we're going to go to variables, y variables, y1, close parentheses, comma, x, comma 0, oops, that's not comma, comma 0, comma, we're going from 0 to 3. It's going to do a little bit of math, it's going to think about this. Don't panic, the calculator is just processing this. Now we got 5.301. But we do need to make sure we write the setup here. So D, our position, I'm sorry, total distance is going to be the integral from 0 to 3 of the absolute value of v of t dt. And it's a calculator active question. We don't have to write any work. We just can write the answer, 5.301. Okay. None of these questions is asking you for units, so you don't need to do that. And the only question that asks you to justify was part B, and then there's always an implication for questions in part A. You need to explain why you know it's slowing down. Okay. All right. I hope this helps.